Hey, this is Presh Talwalkar. I'm thinking of a 10-digit number that uses each of the digits 0 to 9 exactly once, and the first n digits of the number are divisible by n. What could my number be? Give this problem a try, and when you're ready, keep watching the video. There are names for the properties of this number. A polydivisible number has the first n digits that are divisible by n. A pan-digital number uses each of the digits from 0 to 9. This puzzle is asking for a polydivisible number that is also pan-digital. You could write a computer program to run through all the possible numbers, which will be over 3 million possibilities. In this video, we're going to solve the problem using mathematical logic and reduce this down to only 10 possibilities using the rules of divisibility. To get started, we need the 10-digit number to be divisible by 10. This forces the last digit to be 0. Next, we want the first 5 digits to be divisible by 5. This means the 5th digit has to be 0 or 5. Since we've already used the digit 0, this means the 5th digit has to be 5. Just from these two digits, we've already reduced the number of possibilities to a little over 40,000. Let's continue. We'll now consider that the first 2 digits are divisible by 2, the first 4 digits are divisible by 4, the first 6 digits are divisible by 6, and the first 8 digits are divisible by 8. In other words, the first n digits, where n is even, are divisible by even numbers. So that means there must be even numbers in the even spots. I'll denote this by a blue rectangle. Furthermore, we have exactly 4 even numbers remaining to be placed in 4 spots. That means these 4 spots will use up all the remaining even numbers. Therefore, the remaining spots in the odd numbers must be odd digits. Now let's consider the first 4 numbers. We need this to be divisible by 4. The divisibility rule is that the last 2 digits of the number have to be divisible by 4. We also know that the first digit has to be odd, but it is not the digit 5, which is already used. So which 2-digit numbers satisfy this property? We can start counting up from 0 and look for 2-digit numbers that are multiples of 4 with this property. There are only 8 cases to consider. And there's a pattern in these cases. The last digit of the number is either a 2 or a 6. So that means this 10-digit number must have the 4th digit equal to 2 or 6. We'll write out 2 different possibilities. Now we're going to figure out the 6th digit. We know that the first 3 digits are divisible by 3, so that means the sum of the first 3 digits is a multiple of 3. The first 6 digits must be divisible by 6. That means they must also be divisible by 3, and therefore the first 6 digits must also have a sum that's a multiple of 3. Now, since the first 3 digits have a sum that's a multiple of 3, this can only happen if also the 4th, 5th, and 6th digits also have a sum that's a multiple of 3. So let's consider the 4th, 5th, and 6th digit. If we have 2 plus 5, that gets us to 7. Now we need to use one of the even numbers that's remaining to get to a multiple of 3. We can't use 4 or 6, but the number 8 would work. 7 plus 8 is 15, which is a multiple of 3. 6 plus 5 is equal to 11. We need to use one of the remaining even numbers to get to a multiple of 3. We can similarly conclude this digit would have to be 4. Now let's consider the first 8 digits of the number. This needs to be divisible by 8, which means the last 3 digits have to be divisible by 8. So we want to look at numbers in the 800s and the 400s. We also know that the middle digit has to be odd but not equal to 5, and we can't use one of the even numbers we've already used. So we could start counting from 800 and go up multiples of 8. See which numbers satisfy this property. We do the same thing for the 400s. There are only a few cases that could possibly have an odd number in the middle and it doesn't use one of the even numbers that's already remaining. In the case of the 800s, we can't have 832 or 872 because we've already used the number 2 in 258. So we remove a couple of possibilities there. Similarly, for the 400s, we have to remove the digit 6 because 654 already uses the digit 6. So this leaves us with 2 numbers in the 800s and 2 numbers in the 400s. So if we put those in, we have 4 total possibilities for our number. So we've actually filled in a lot of digits of this number. We can even fill in one more digit. We have exactly 1 even number that's remaining. This has to be the last even digit. In the first 2 cases, that'll be 4, and in the last 2 cases, that'll be 8. Now we have exactly 3 digits remaining in our number. These will be odd digits. In the first case, it'll be 379, then 137, then 179, and finally 139. So how can we reduce the number of possibilities further? Well, we need the first 3 digits to be divisible by 3, so the sum of the first 3 digits has to be a multiple of 3. If we look at our first case, we have something for something, and we need to have 3, 7, or 9 in these places. We can try to figure out sums which have 4 in the middle that'll get us to a multiple of 3. None of these are going to work, so this entire case can be removed. We will never get something that'll satisfy the property we want. Let's look at the next case. We have 1, 3, and 7, and 4 in the middle. So 1 plus 4 plus 7 is equal to 12, which is a multiple of 3. So we could have 147 or 741. We'll do the same thing for the next case. We have the digits 1, 7, and 9. Now there are a couple of sums that get us to a multiple of 3, so that leads to 4 different possibilities for the numbers. The final case is similar. There are 2 possibilities to get to a multiple of 3, which leads to 4 different cases. So we have 4 plus 4 plus 2, which is a total of 10 different numbers. So we've reduced this from over 3 million numbers to check, and there are only 10 possible numbers that this could be. Now, which number is the answer? Well, we still need the first 7 digits to be divisible by 7. So you could check the first 7 digits, divide it by 7, see which one's divisible, and there's only one number that works. This is 3,816,547,290, and that's our answer. Did you figure it out? Thanks for watching this video. Please subscribe to my channel. I make videos on math and game theory. You can catch me on my blog, Mind Your Decisions, which you can follow on Facebook, Google+, and Patreon. You can catch me on social media at Prashtalwalker. And if you like this video, please check out my books. There are links in the video description.